Hello, everyone. Good morning, good afternoon, good evening, depending on where in the world you are. I'm Tony Ogg from Nimble Gravity, and I'm joined by Kristóf Rábay from Hiflylabs. And we're really excited to talk to you about some research that we've done, as well as our experiences in our respective companies, both of whom are consulting companies that work very closely with generative AI. So will first walk through our generative AI adoption report. So this is the research that we did in August that covers, really the journey from idea to production around generative AI use cases, talking about what makes for a successful implementation, how long these things tend to take, a little bit of an industry-specific view across a couple of different industries, and some experiences that we've had in driving these projects, as well as bridging from there into AI agents. So agentic approaches are both, I think, kind of what's most exciting in practical use cases today, as well as something that helps address some of the things that have made PoC or proof of concept to production difficult in sort of the pre-agentic or pre-agent approaches for how to do Gen AI work. So our goal today, we want to provide some interesting, actionable insights for you around, what makes a successful or not successful Gen AI implementation. Talk a bit about sort of inside of that, what the hurdles have been and why maybe that has something to do with some industries being successful and others struggling a little bit. And then overall, some tips and tricks for how to better prepare for innovation, specifically with Gen AI, because it is a little different than maybe some other types of innovation around technology. So a bit of background around the survey that I mentioned. So we got 460 respondents to our survey, all of whom were AI decision makers globally across 14 different industries, which included things like technology, healthcare, manufacturing, finance, etc. All of whom had to meet some minimum requirement for their involvement in Gen AI projects, and all of whom needed to be decision makers or active contributors to those Gen AI projects. So this was a survey that took people roughly 15 minutes to fill out, and it was conducted 4 months ago. So at a really high level, if I describe the funnel, and we chose some delineations in a funnel. So the first step, the darkest one here, we called assessment, and this is let's explore some ideas, let's come up with an evaluation framework for these ideas, and let's ultimately build a proof of concept. So something that's is there a there? Does this idea work? Can we use Gen AI to solve this particular problem? Followed by, if that is a yes to that, we can solve this problem, then some type of a pilot. So a limited deployment, something that is actually being used by a business in the quote normal settings for that business. And if that's successful, moving on to production. And I think probably our definition of production here is a universal one. So it's widely adopted, it's operating, it's functional, et cetera. And when we use these delineations, roughly half, or 53.1% of Gen AI initiatives in the survey respondents made it to the pilot phase, and then roughly the same percentage of those made it to production. So you see like a dropping off. And I think kind of when you think about that across different industries, we looked at this in sort of the mid-size in our definition. We're a bit above that percentage. So we think mid-size companies tend to have fewer, fewer risks than big companies. So big companies tend to have more rules and more IP to protect and so forth. And small companies simply may not have the use cases or the people to go execute them. So there's sort of this, like, where we saw the most success was around this middle size of the group. And I think when we take the 53 and the 52 and apply some simple math to one another, roughly 28-30% of projects go from that assessment phase to production phase. And I think at a high level, I'm incredibly encouraged by this for a couple of reasons. One is, even though the number in a broad sense seems relatively low, the good news is that companies are willing to experiment and try new things, sometimes with the idea that maybe they don't all work, but experimentation, number one, is a good thing. The second one is probably like whether they made it to production or not. It's, organizations are getting educated on how to think about employing Gen AI techniques and how to leverage them and so forth. So they're educating themselves and getting up to speed with maybe the types of use cases where they would be more successful. And then finally, like, my hunch, and unfortunately the survey didn't get into this, the next one will, is that I think probably in some cases companies are trying too many things, and they're not enough focus on sort of, let's make sure we're limiting the number of different things we're attempting with the goal of getting the most all the way into a production environment. So there was a couple of things in the chat, just checking on whether any of them are active questions or not. So I'll just keep going. So when we think about failure and what came back in the survey for reasons why companies weren't successful, you see here on the page kind of the number one in terms of the number of responses, and note the sum here is much greater than the number of respondents because some people cited multiple issues. The top one is incompatibility with tech infrastructure, and frankly, I think, given in our experience, probably very little or in some cases no actual tech infrastructure is truly required. I think there might be some sort of barriers in the thinking about what is needed to be successful, or perhaps like there's some creative ways to avoid thinking about it from I don't have a cloud solution yet, maybe I need AWS or Azure or GCP. I think in our experiences, that, like, this one is kind of an unexpected one, just given that you can call an API for many of these foundation LLMs and get results back and start to include these. The high cost was also not unexpected, but also somewhat surprising that it was at the top, just given that you can, unless you're processing huge amounts of data and driving lots of calls and lots of tokens, which is sort of the denominator of cost, you can at least try some things. And I think also just the cost of these large language models has been coming down from a sort of quarter on quarter basis. They keep getting cheaper. But I think if I take a step back and kind of summarize maybe on the failure side, one is are the use cases being attacked or attempted with these really the most valuable ones to go after, or are they kind of in experiments without maybe a true reason to go all the way to production? So is there a return on the investment? Are the models good enough in some cases, or are people creative enough to use models that are maybe still have some hallucinations or some issues to drive to that next step? And then some of the other reasons are probably generically the types of reasons why any project might not make it to production. Did we get did we plan well enough for what we could do here? Did we get all the right stakeholder buy-in? Did we not really focus on it and try hard enough? I think those are kind of generic ones that aren't specific to any specific OpenAI or LLM type of reason. Then we looked at timing and timing from kind of how long does it take to get people through or projects rather through the assessment phase, and then through the pilot phase to a production phase. And remember here, the proof of concept or PoC type project is in that assessment phase. And the really good news is, like, in something like 20 days, most of the survey respondents, in this case the average, got through that pilot phase. So coming up with an idea, evaluating the idea, and building a quick proof of concept. And that's been our experience too, is that given the the flexibility of these models and how these things work, you can spin one of these up relatively quickly. And frankly, I think in some cases you can in a way you could use something like a Claude or a ChatGPT to test out your idea and see if through some prompts and these kind of things you can get a response that leads you to believe that if you take the next step and start writing some code or building a real software, you could achieve what you want to achieve. Then from that sort of assessment phase into a pilot phase, we saw something like roughly twice the time that it takes to get through the assessment phase. So circa 5 weeks, 36, 37 days. Let's get that rough proof of concept through to something that real users can use in real business cases and start delivering value to an organization. So let's figure out how to deploy this and get it into the hands of people. Let's make sure we have tested all the use cases and we've put controls around the GenAI to ensure that the outputs are good. Those types of things I think are a little harder, and that's why it takes from a pilot phase might take roughly twice as long as the assessment phase. And then finally, getting into production could be a variety of different reasons why that could take longer or not. But we didn't really. There's no end to a production phase, so there's not an end here in this book. From an industry point of view, and I have to point out that the x-axis is sort of the opposite of what you might expect. So the shortest times are on the right. Here, this is interesting because honestly, like, agriculture was surprising that they would have both the fastest time through the processes mentioned on the prior slide, as well as the most number of projects. And I think that's potentially because it's not a super regulated industry. Maybe they hadn't adopted a whole lot of technology. That's just a hypothesis that I have. And potentially they just were more ripe for interesting innovation, as opposed to further to the left here. It's no surprise that healthcare takes longer. It's regulated. There's data privacy concerns. There are issues with health information that need to be considered and handled, or obfuscated, or removed, or something like that. So it's not at all surprising that in more regulated, bigger, typically industries, that they might both have fewer different things that kind of get through that assessment phase, as well as take longer for each of them. And the bulk of between 45 and 60 days is where most companies tend to seem to, or most industries rather, seem to center, as well as sort of like around 15 different projects over the course of the prior year leading up to the survey. So I think there's sort of this idea that maybe if you look for simpler use cases and you avoid some of the data stickiness, if you will, in terms of PII or PHI or any other regulated type of thing, tends to move a little quicker, and maybe fewer projects as well. Okay, so now let's talk about success. So in looking at all of the use cases through this survey process, the top use cases, no surprise, research, summarization, and any sort of extraction of information. And LLMs in general tend to be really, really good and excel at processing huge amounts of information and extracting some sort of meaning or some simplification or summarization of that. That could be techniques like retrieval augmented generation or RAG. It could be other techniques, but that was one that stood out as a really successful use case. Second one is automating any sort of repetitive task. So looking for something that happens over and over and requires manual effort. We've seen use cases where it's looking at emails manually every day and processing those. Doing something that is sort of routine and manual and text-based and hard to automate through other kind of technology. Frankly, the LLMs tend to do a really good job at that. Obviously, coding assistance, so tools like Cursor are being deployed, tools like GitHub's Copilot being deployed. So the coding assistance, I think those are simple to deploy because you don't have to really do a whole lot other than make sure you're comfortable with the technology and how to use it. And B, I think they're logical ones. Technology people tend to be pretty quick at adopting technology. And finally, I think customer relations is maybe not the best term for this, but any kind of customer support use cases tended to be pretty successful. And there's a couple of reasons, I think, for wanting to do that. One is there's often a lot of manual activity related to supporting customers. So that could be, customer service and, responding to chats or phone calls, those kind of things. And the other one is not only can you make those processes more efficient, so improve the experience of the customer if you do it right. In other words, am I getting a really accurate answer almost instantaneously when supported by an AI? Or am I taking hours to get a response and maybe it's not super clear because a human responded and maybe they're new at the company and they haven't read hundreds of pages of documentation that an LLM can frankly look at. So I think those are sort of the use cases that came through as being generally the most successful, and connected to those are some benefits that are the obvious ones, like people looking for time savings, people looking for cost savings. So where are those places where I can return a quote to a customer faster? Where are the cases where I can take hours of manual work and make it a faster process? So I think those are the obvious ones. Let's go look at automation of workflows and processes that prior to a computer's ability to understand human language might have been really difficult to automate. Now we can automate in a much more straightforward fashion. Those are also really good benefits. And then finally, I think the unlocking the knowledge of an organization through exposing all the information, what it actually means, is pretty interesting, useful stuff. So imagine in some cases it's the let me go effectively talk to my data. So instead of it being let me figure out how to take all this data and put it in a data warehouse and then make some Tableau or Power BI reports, which is still, don't get me wrong, still very valuable. Let me go ask the data a question of itself. How long is the average shipping time, or something like this? And I think that the LLMs are getting better and better at those kind of cases. And just to extend on that, from our own projects between Hiflylabs and And Nimble Gravity, here's some kind of example benefits that we've been able to achieve with these projects. So we helping a financial services company really took out all the time to do some uh, uh, financial analyses. So this is like going from lots of people taking lots of time to basically pushing a button and doing it 100% automated. Another one is, helping an electronics manufacturer, retailer respond to customer support requests. There's still the harder things that maybe a human needs to get involved with, but half of the workload rather got automated. Improving knowledge base access, reducing the amount of repair time due to ability to look things up, or in the last one here, completely automating a customer service function, which was 30 individuals, and that happened in the course of about 10 weeks from zero to fully in production. Resulting in an annual savings of roughly $1 million. So there's some, real savings and real things. These are just a handful of examples from our own work. As we've gone through these projects, as we've been since the days of GPT-2, kind of working on projects like this, there have been a number of adoption success things that we've come up with, and this is roughly 10 of these that we'd like to share. So the first one is making sure people really understand what this technology is able to do, setting appropriate and realistic expectations. So sometimes we encounter people who think this stuff is magic and you can just ask an AI to do something and it's going to do it. And that's sometimes it feels magic, but it's really not magic. And understanding what the realistic expectations are important, noting that these things are evolving really quickly, and that takes some work to stay up to speed with what is possible, but it's not magic. And understanding what kind of use cases are going to work is important. Second, like understanding how AI can be applied in conjunction with specific goals and process, versus let's just go play with it and see what happens. I think that the guiding principle here is, and the direction that we've seen most successful is look for the things that you tried to automate sometime in the past, but it was too hard because there were too many manual steps. That's probably a good place to start. That's not a universal direction, but it tends to be a pretty good place to start. So the third one here is like sometimes it's just to trying new things. So I think I'm I've been around long enough to see there was a resistance to moving to the cloud because you can't go look and touch your data like you used to when it was down the hall in a closet in a rack. Same sort of thing. So there's just some education and getting comfortable with this, understanding what the terms of use say and what the ownership rights and so forth are around the data, understanding getting the legal team to look at it quickly to make sure they're comfortable as well. Education is important. So this technology has come out and grown so fast that I think sometimes it takes a bit of a workshop situation or some like let's do a brown bag lunch education to get people up to speed at some sort of baseline level of what is possible, how does this work, how do we use it. It is changing quickly. It is frankly impossible to keep up to speed with everything, but like as people experiment, as people learn, share, how do you share those things? How do you go keep yourself up to speed? Education is incredibly important. I think if we look at what's happening in the market, other case studies, the case studies we've shared today, I think those are helpful for understanding potentially where your own use cases could happen. I think understanding what others are doing, talking to friends, et cetera, I think is helpful. Um, and I think kind of the rest of these tend to be sort of generic. Like when you have a project, try to have a what does success look like before you really get too far. So you idea of what are we really trying to achieve? Is it good enough that we saved 50% of the time? Do we want to save 90% of the time, or automate 80% or 100%? I think some of those are super important for any kind of project, not excluding Gen AI projects. Um, you know, as there aren't a whole lot of people doing this in the world yet. I think getting experts to help can be a good thing. That might sound like I'm trying to sell people something, but I'm not. It's, I think across any kind of new technology, you might want to, if there are use cases that you think are realistic, consulting is a good way to test the waters. I touched a bit on this, but sort of obviously there are lots of privacy and ethical concerns, and what decisions are being made by an AI, and there's an evolving framework of legal things. So can a AI take an automatic action on deciding if somebody gets a loan or not? These types of things are a little bit of a new horizon, Wild West, and not super well defined. So I think there are ways to proceed with caution, and there are also ways to proceed with less risk by looking at use cases that maybe avoid some of these things, or at least um, have less potential risk as you think about them. But certainly, we're not providing legal advice. Talk to your legal team about those things. I think once upon a time, people should I buy the iPhone? Should I wait for the next one, et cetera? Like at some point, uh, when technology is evolving at the pace that this is evolving, probably the worst thing to do is wait, because those internal skill capabilities, the sort of how do we make use of this, all of those things are not going to stop. Probably the least AI enabled we will ever be is today. And the least data enabled we will ever be is today. So waiting until maybe GPT-5 comes out to try something, like, you will always have that regret. And I think continuing to just think about where it may, and understand that maybe 6 months or a year from now you'll have something better to try, is just part of the game. And finally, like, I think again, this is kind of not a surprise, and not limited to the Gen AI type of projects. Like sometimes the hardest part is getting data into or out of legacy systems. Um, and how do you do that? Uh, and I think the good news is some of these techniques, and we'll touch a bit on this later, actually start to change how easy that is, and change what's possible, and we'll touch a bit on that. Okay, changing topics just slightly. So, as we thought about what are the barriers to adopting Gen AI, one of the things that we've seen um, being really successful and having a lower barrier to adoption are agents, agentic approaches. And really what we're talking about here, and we'll go into much more detail around this, is you're getting Gen AI's help to use Gen AI. So you're providing high level instructions of, please automate this process for me. And you're enabling the agents with tools that allow them to go do those things, and they come up with their own plan. And, there's still work involved, obviously, but the level of what's possible becomes much simpler, because you're leveraging the tech to drive the tech, which can dramatically simplify the time to value and improve the chances of success. And we're going to walk you through some examples here.
So, thank you, Tony. Can you confirm that you can hear me well?
Yes.
Awesome. So let me share my screen. We're just going to keep on doing this presentation from the same slide. It's just we're going to have a live demo at the end, so it's just going to be easier for me to switch between tabs. All right. Can you also please confirm that you can see my presentation now?
We're good, Kristóf. Thanks.
All right. Awesome. So we have talked so far about um, the benefits of using AI, and especially towards the end, we've mentioned AI agents. So let's actually start with defining what AI agents are. So I think, Tony, you and I both have experienced that different people with different job roles, they give different definitions to what they think an AI agent is. So really, there are two types of definitions that we can come up with. There's the business definition, in which case we can call anything an AI agent if an AI instance is really prompted to act as an expert. So I think we've all sort of played with OpenAI or ChatGPT and asked it, hey, act as a senior Python developer, help me come up with some code. Or we have played with Claude, act as a seasoned blogger, help me write an article. That is really just prompting the agent to do something very specific, and that already can actually be defined as an AI agent in the business world. But on the technical side, really what we call an agent is still an AI instance that is prompted to do something specifically, but we give it the option to call some tools. So if you go on chatgpt.com right now, and not using the web search, and you ask, what's the weather in San Francisco? It's going to say, I don't know, because real-time information is not provided into the LM. The LM is trained, the training data is cut off at a certain point, and then beyond that, we don't know what's happening. But if we give a tool to the agent, let's say a weather API, and we ask a question, what's the current weather in any given city? It's gonna reason, because one of the biggest assets of the LLMs is that they can reason. It's not their internal knowledge. It's also their insight extraction, but really it's the reasoning capability. It can reason that they don't know the answer, but they have access to a tool. So they can call the tool a weather API or just a simple web search engine, and they can actually get the current real-time information, and they can present it to the client. So really these are the differences between how we can define an agent. All right. And actually from what we see is 98% of what we call AI agents actually refer to the business definition. So that just means that currently almost no one is giving too much decision-making capabilities to the agents. Really, we're just prompting them. We are coming up with very detailed and specific prompts called prompt engineering, and we're calling those instances of the AI as an AI agent. All right, so let's step back. I think we can sort of feel that we switched to a little bit more technical approach here. So in machine learning, why do we want? Why are we using multiple agents? Because there's a shift since ChatGPT came out. There was RAG, there was agents, and now it's multi-agent or multi-agent systems. And why is that? So in machine learning, there's a concept called weak learners and strong learners, and there's a specific model called a random forest. So there are machine learning models called decision trees or trees. Some of them are weak, some of them are strong, but together, as they're giving predictions, together they can actually come up with a very strong prediction. And if we combine multiple trees, we sort of get a forest, hence the name random forest. And applying the same thing to agents, it is very beneficial not to use one agent for everything, but use multiple instances of agents, each specifically focusing on one separate task that they are very good at, and sort of using the combined power of them. So let's give an example. So let's say I am KSPM, the sports analytics company. And every morning or every Monday, I want to come up with a brief with an AI agent, multi-agent system. So I want reports on different sports, different leagues, different teams, and I want to deal with agents. So why is that beneficial? Well, number one, if we're using multiple agents, we can have specialization. Each agent can focus on a separate area. If it comes to sports, it can be just leagues. That's most simple to explain. Number two, parallelization. So we don't have to wait for an agent to finish their task before asking a second agent to run. So in this case, if we're focusing currently on 3 of the top professional leagues in America, we can sort of ask those agents to do their research, come up with their brief, what happened last week, present me with top games, highlights, scores, whatever you want to extract from that. Number 3, scalability. So far we have 3 leagues in our multi-agent system. What if we want to add college sports? What if we want to add baseball? What if we want to add soccer? So if we're using a multi-agent system, if it's set up in the correct way, and we're going to get into that, how to do that, then it's a very scalable system. And you can have, yesterday you may have 5 agents working together. Today you may have 100 agents. It's not that easy to scale from 5 to 100, but the option to do that is actually there. Number 4, resilience. That's probably one of the most important parts of building a system, because the more complex it gets, the more agents you have, the bigger the chance of actually breaking. So let's say for some reason the NHL agent, insights from hockey games, breaks for some reason, cannot extract data from a database, or for some reason, its API connection breaks. That doesn't mean that the entire system is going to break. That just means that our final brief about sports is going to mention that, actually, sorry, the NHL agent could not complete its task. But still, every other instance of agent still runs. Number 5, we have a very flexible design. So the more agents or the more workers or interns we add to the system, the higher chance that it can become hierarchical. So for example, currently we also see that 3 out of the 4 agents are professional league sports and 1 is just college sports. So if instead of having all the agents reporting to a orchestrator or supervisor, we can actually group them and have a sub-team of professional leagues, a sub-team of college leagues, or we can even go within the NFL. For example, we can break it down, some team focusing on the AFC, some team focusing on the NFC, or different divisions. So really the flexible design is super important to make this whole system scalable and maintainable. All right, but the problem is that just as managing a team of people, sort of we need to enforce effective communication. Otherwise, we're not going to know what person A is doing. We don't know what person B's job, how person B's job affects person C's job. So really, it's the same thing with agents. We have to enforce effective communication, and that's probably the biggest challenges right now, even in research, because there's 3 things we must accomplish. 1 is the agents have to share information somehow. Otherwise, everyone is just going to be locked in a room. They don't know about each other. They're doing their own thing, and they're not working towards a common goal. Number 2, as I mentioned, one of the biggest powers of LLMs is reasoning. And for them to do that, for them to like complete their task, to make the reports, comprehensive and readable, they need to take different steps. So either the supervisor or even just a reporting agent needs to know what's the next step to take. And finally, agents, it's basically compute, so they can go on forever, really. So we also need to identify when to end our flow. If the end goal is to come up with a sports reports of all the leagues in America for a day, then we sort of have to identify when do we have enough information to stop the insight generation, insight extraction, and sort of just present to the end user, this is what we have. Okay, so how to enforce this effective communication. This is a pretty technical slide. So we want to present some of the approaches that you may take, and we have taken in the past, in terms of how we can set up our team of agents. So we have highlighted 3 of what we think are the most commonly leveraged approaches to setting up agentic teams. So on the left, you see an orchestrator. That really means it's a supervisor. It's self-explanatory, I believe, that there is a supervisor which has to be the smartest agent. It gives orders to the subordinates. and they have to do their performing, they have to do their research, and they have to report back to the orchestrator. This is what we saw with the KSPN sports analytics example before. We have a supervisor, and they decide, I'm going to call the NFL agent, the NBA agent, the NHL agent. I'm going to wait for them to report back to me, and then I'm going to sort of call it a day, say, we're done. In the middle, we have agent-to-agent communication, which already seems more complex. It's very decentralized. Everybody can call everyone. There's not really one agent that is designated to be a supervisor. So here, all of the agents need to be very smart in terms of making decisions. Who is the next in line? What orders did I get? How do we proceed? And then there's on the right, you see something called the shared message pool, which you can think about as a group chat. So think about, you have a group chat with your friends, and you're about to watch Thursday Night Football. I think you have a sense of, I'm a big NFL fan, so let's just stick to it. You're going to watch the Thursday Night Football game with your friends, and you have a group chat, and you just send a message, I'm out of popcorn. But you don't give an order like, hey, Alex, please buy some popcorn. So all the agents, all the people see this message, and one of them is going to pick it up. So one of your friends is going to say, I'm on my way to Sam's Club. I'm going to buy popcorn for you. So here, you sort of see that agents do not give orders really to each other. They just sort of see what's happening in the middle, and then they have to make a decision. Are they the ones to act next? Are they just going to wait for someone to take this task? So it's also very decentralized, and it can introduce a lot of challenges and bottlenecks, and we're going to get into it in a second. So this is a high-level overview of like 3 of the approaches that we present here. And the important thing to know is these are, first of all, not exhaustive, and these can be combined. So within the agent-to-agent system, you can also have an orchestrator, or you can have a team of agent-to-agent systems. All right, so let's go into the first row of the table below, which is the direction of the communication. So in the first case, we sort of see the orchestrator gives instructions to the agent reports back. It's pretty simple. In the second one, in the agent-to-agent, an agent can give an instruction to specific agent or agents, and then the agents will have to complete the task, and the agent who completed the task will decide who is next in line. And then in the shared message pool, as I explained, there's basically it's a group chat. Everyone reads it, and they can decide on their own, am I going to be who's going to complete this task, or am I going to wait for some of the other members to do it? Okay, let's go to visibility. In visibility, in the orchestrator setup, orchestrator sees everyone. They're the supervisor. They have to be the smartest model because they make all the decisions. Who acts next? When do we end the flow? But the agents who are reporting to the orchestrator, they only see the orchestrator. So agents don't see each other. They only report back to one common person, and that is the supervisor. In agent to agent, obviously all agents can communicate with each other. But once an agent calls an agent, once agent A calls agent B, then agent B sees the instructions from agent A, and then once they complete the task, they can call A, B, C, D, etc., etc. And in the shared message pool, obviously all agents sees everyone's inputs, and this is gonna be the most complex one, which is why we have the last row for the bottlenecks and challenges. So obviously the orchestrator, as I mentioned, needs to be very smart. It needs to be able to reason very well. And currently we see a shift in LLM research. We are seeing reasoning models coming out more and more. We have an open source model. Obviously, the first reasoning model was OpenAI's O1 preview. Now we have some open source alternatives to it. We also have Anthropic is working on, they even came up with an idea how to prompt their existing models in a way that they can reason better. So there's a shift towards coming up with models with much better reasoning capabilities. So really, within the orchestrator, the only bottleneck really to be smart. Within the agent-to-agent framework, because it's very decentralized, well, this can be an anarchy because the agents will call each other. They can go forever. They need to be able to know when to end. They need to be able to take instructions. And as the communication increases and as the complexity increases, information may get lost. So there's still a technical constraint within to the LLMs, which we're gonna get into. And really, shared message pool, agent to agent, they are sort of suffering from the same challenges and bottlenecks. All right, so we sort of have setting up the communication and coordination, and we need to tackle the challenges that come with it. So number one is obviously complexity. We've mentioned it. Even the orchestrator setup can be very complex. The more agents we add, the harder it gets for the orchestrator to act correctly. And within agent to agent, as we can see, if there's a 10, if there are 10 people in a group, it's sort of maintainable in terms of like, you know each other's names, you know who does what. But if it's 100, you sort of forget. You need to make sure you're calling the right person. So as we can see, we can introduce a lot of complexity into that. So number two is, as we build these systems, we have to sort of we sort of feel the shift that we're stepping back from human in the loop. So we're giving more control to the agents, which because it introduces autonomy for the agents, we are going to be experiencing a lot of unpredictable behavior, because really we're not going to be able to just simply control who is going to act next or when the flow is going to end, if we want to give the whole reasoning capability to the agents. So if we want to have a fully automated AI agent system, we have to trust in a way that we trust that even though they're given a lot of control, a lot of autonomy, they're going to behave properly. And number three, there's a technical constraint still with the LLM. So context window is obviously the biggest one. Each AI basically has a memory, so they can read a certain amount, they can write a certain amount, they cannot go really beyond it. There's research going into how to sort of make it a continuous loop, sort of maintaining a short-term memory, a long-term memory. So there's research around that. Leveraging fixed context window LLMs sort of for longer context, but there's also research into how to develop the LLMs with much larger context windows. So for example, Google has a model that has 2 million tokens of context window. Compared to that, Claude, OpenAI, their models are usually up to 128K. So there's a huge difference between sort of the capability of one model and how much it can memorize and versus the other one. Right, so we sort of see that there are challenges to setting up these multi-agent systems. We want to keep control over them because otherwise they're going to be unpredictable. So this is where agentic comes in. So there's also a little bit of a difference between what we call multi-agent versus agentic. And agentic really is anything that can be described as sequential or pipeline-esque, pipeline-like process. If we know the steps we want to take, then we can introduce a lot more determinism, and with that, a lot less hallucinations to our pipeline, because we know basically in which order we want the agents to complete their tasks. We know basically who should be talking to whom, so we don't need like a fully decentralized system. We can just set up different routes that they can take, like agent A can only talk to agent B, but agent B can talk to C, B, C, and A. So we can have more control over our system. If we know the steps we're going to take, and if we know what agents we're going to initialize, if anything breaks, it's much easier to identify and fix bugs within the system. And one huge benefit, even though we're sort of not giving full autonomy to the agents, we're building agentic systems, we're still producing at the end a team of agents that are working towards a common goal. And a quick example on this is, I think Tony mentioned this one too. Let's say we have complaint emails or complaint letters, and this is a process that can be modeled. So if we have an incoming letter, a complaint letter, we can have an agent that first takes a look at it, extracts the intents of the user, what was to their disliking, it can summarize it, then it can pass this information to the router. The router can route this extracted information to different workers, maybe different departments that have different you can sort of cover financial complaint or legal complaint. Once that job is done, we can pass it to a synthesizer. A synthesizer can actually combine and consolidate all the inputs or all the outputs of the department experts. And at the end, if it was a letter or an email, we can also ask an agent to basically draft a response. So the entire a complaint email or complaint letter process can be assisted with an agentic system. All right, so what have we done so far? We have identified that there are different definitions of agents. We understand why it's useful to have more of them and why there's a shift, and not why, but that there is a shift in AI development towards building multi-agent systems. And we've also seen some examples how it's difficult to set up a correct communication and collaboration pattern between them. So now let's see a demo. The demo is going to be, we're going to use this an orchestrator setup. And the end goal is we want our personal morning briefer. So we wake up in the morning and we want to have sort of a report about our area or our city, what's happening, what's the weather like, what's going to be the weather like, what are some sports news, some financial news, local news, and we want it to be presented in a nice format. And one of the things I haven't mentioned is obviously there are many providers. There are closed source models, open source models, and in a multi-agent system, you don't have to stick to one, and you shouldn't, because different providers are excelling at different parts of how we can sort of quantify the performance of the model. So really writing, that's been Anthropic mostly. Coding, well, coding has also been Anthropic. Anthropic is very much on an uptrend. Reasoning has been OpenAI. So really, you can select your own models. Long context windows, that's Google. So really, you can play with it. You don't have to stick to one provider. And obviously, if you want your own, you can just swap it to an open source model. So we're going to be using LangGraph, and the demo should be quick. So we're going to have some time for questions. We're going to exit the presentation, and we're going to use LangGraph Studio. So here you sort of see that we set up this agentic system. We have the supervisor. The supervisor is going to get an input, and once everything is done, we're going to have an output. We have our agents. We have a weather agent, a sports agent, market news agent, local news agent, and the final responder. Basically, these four, they are doing their research, and then this one is basically guessing. Takes everything that's been gathered and puts out a report. Now, mostly I'm using OpenAI, and there have been some outages, so that's another thing you should keep in mind. If you want to stick to an API provider, you sort of have to have a backup plan. So let's say I've been working with some people from Detroit. So let's say I live in Detroit, Michigan. Can I have my morning brief, please? All right. So what's going to happen? First, the supervisor is going to call the weather agent. Oh, one thing I forgot to mention, this is sequential for the purpose of the demo. So you sort of see like what are the steps we take. So we called the weather agent. The weather agent came back to us with some weather information for today's date. Then we're going to call the sports agent. We want to get some news for Detroit. There's actually a Detroit Lions game tonight. So maybe that's going to be part of the output. And all these agents are connected to the internet because we need fresh news. So all of them are actually tool calling agents, like technically. So this is not the business definition of the agent. This is the technical definition of the agent. And we sort of experience some latency. So hopefully it's going to run through. And by the way, the APIs that we're using, like there's a separate weather API for the weather agent that's also connected to the internet via web search. So they are looking for news. So hopefully that's going to happen. If not, we're going to call it a day and we're going to come up with the video. It always happens during the demo. Okay, well, we have our insights, hopefully. Yeah, well, there's a lot of things that we have. We have some info on the Lions, on the Pistons, Red Wings. Okay, so now the supervisor got the insights from the weather, from the sports. Now it's calling the market news agent. That one already ran through, so maybe there's something with the sports API. Anyways, we're now at the local news agent, so we're asking for some local news from Detroit, maybe some accidents or road closures. I think there has been snow, so maybe there's something around that. And once the local state news agent also returns with their output, we are going to see that the supervisor should now actually call. I think we are sort of having. Oh, no, it's all fine. So now we are at the final responder agent. We have gathered weather, sports, market, local news, and we are now calling the final responder agent to put together the report. I think we can wait for it a little bit. Okay, and done. We're done. So we see that the supervisor said we can finish because we have everything. The final responder agent has already compiled and delivered the complete morning brief covering weather, sports, market, local news. Therefore, the process is complete. So what is our output? Our output is basically a report. I'm sorry that the rendering is not so nice. I can sort of cheat a little bit with this because we can just put it into a markdown viewer, and this is what it came back with. So you see, for today, we have our weather in Detroit, sports updates. Lions are preparing for a significant game tonight, and that's it. So I think we can go back to the slides. We have seen the demo, and I think Tony, I believe,
Yep.
I can back
Yep.
the mic.
Thanks. Yeah. Thanks, Kristóf. Yeah. So I think just sorry, you're on the mark. There you go. Back to the presentation. Thanks, Kristóf. Yeah, so I think, when I think about agent and agentic use cases, here are a few more just to think about. So one is, kind of this enterprise knowledge base. Let's ask questions about what's there. And one of the things that may be interesting to mention is people can also be called as tools. So Kristóf's example was looking at a news API and a sports API and a weather API and bringing that information back to summarize a daily response. Well, it could also be, let me ask a question of my organization. Maybe there's no document that's a great answer. Let me ping somebody in some department and ask them the question too. So you can think about these as kind of ways to bridge some of the tech and human workflows. It's pretty interesting. The second one is order management and supply chain, and this one I think is really fun because you think about the way an order management team or a supply chain team might work. So think about a team of agents. There's somebody called the supply agent, and somebody called the demand agent, and somebody called the purchasing agent, and then you have the alternate sourcing expert agent. And you think about them working as a team with some orchestration to solve an order management problem, or in the case of maybe healthcare, you can think about it as well, I have a tool for checking whether the document is complete, and I have a tool for is the name of the person on this document the same name as the person that the case is about. And then I might have specialist agents that are checking for, allergies or ENT things or whatever it is, and then going to a human to verify that what the agents came up with. So I think these are just a few other kind of use cases just to mention that I think are kind of fun just to plant maybe some more seeds for that. Let's go to the next one.
Yeah, and I'm not sure how we're doing on the questions.
I think so far, if anyone has additional questions, please pop them in the chat. And we have a couple more things. I think, Kristóf, you can just keep going on this.
Yeah, we're just closing out. So I think what we've seen so far is what can we take away? So number one, agents alone aren't enough. This is why we're sort of shifting towards a multi-agent system. And as Tony mentioned, humans can and should be also involved still in the process. Obviously, there's research going into how to fully automate things and fully have humans out of the loop. But building the systems, obviously we need humans, maintaining the systems, testing it. I think it's we have quite some time until we can fully trust the system to just be completely autonomous. Number two, maximizing LLM potential. As we see, these LLMs, these models, they are really good at reasoning. They are getting really good at tasks that they're really getting good at general intelligence. So we are sort of on a path, if people have heard this AGI. So we are sort of trying to train models that have human-like intelligence, and we can work around it. We can work systems around these. We can build systems around these smart models. And number three, you've seen my demo. It was built with LangGraph. LangGraph Studio. LangGraph is just one of the frameworks. There are many, many frameworks out there. So now it's a jungle sort of. So really, for successful projects that make into production, it's a very important decision to make what frameworks we're going to be using. And you may need to switch frameworks because every day there's a new one, every day there's an update, but still that's essential that the framework you use is maintainable. It has a support team around it, so it's not going to get outdated. And then hopefully it's going to take your solution into production.
Yeah, and
Tony?
I think and again, thanks for joining. I know we're at time, but there have been some really interesting computer use examples. So the tool is your computer. So I can prompt, please open up the tab in my browser with the CRM and update customer X. So there some of these things that are sort of board robotic process automation, RPA, for those familiar with it, we're doing. And I think that the future is really exciting and bright, and lots of exciting things. And thanks again for joining, and hope everyone has a wonderful rest of the day. Thanks so much for joining.